Let's continue with naming ionic compounds. So the last type of ionic compounds that we're going to name are compounds with cations that have more than one charge. So compounds with cations that have more than one charge. Okay. The cations that have more than one charge are transition metals. So transition metals often have more than one charge. And this is because they make multiple ions. Okay, so if they have more than one charge, that's because they have multiple ions. Okay, but we're going to follow the same steps when you name these. The first thing you do, well, actually erase that. So naming these guys, you name the cation. With a Roman numeral in this case. The Roman numeral represents the charge. So the Roman numeral is the same as the charge of the ion. After you've named the cation, so after you name the cation, you name the anion. Okay? So we name the cation and you name the anion. In this case, with transition metals that form ions with multiple charges, you need to represent the charge with a Roman numeral. Let's look at an example. So let's say we have PbCl2. Okay? This is the cation is lead 2, and the anion is chloride. It's a chlorine, well, it's the element chlorine, but the ion is chloride. Okay, and so this is lead 2 chloride. Well, how do I know what the charge is? This subscript right here kind of tells us the charge of the other ion. Okay, so remember, let's say we have PbCl2. Okay, so remember, we have a Pb, or lead. It's an ion, but we don't know the charge yet. But we do know the charge of chlorine, and chlorine is Cl-, right? Well, this subscript tells me that I have 2 chlorines, and so I have Cl- and Cl-. The overall charge, or the charge of an ionic compound, is neutral, meaning it's 0 is the charge, right? Well, if I have 2 chloride ions, that means the net charge of these is 2-. So the chlorine part, this part right here, the chlorine part of my compound gives me an overall charge of 2 minus. Well, if I need an overall charge of 0, that means that lead must be giving me a total charge of 2 plus in order to balance out the 2 minus that is coming from these 2 chlorine atoms. And so that's kind of how you can figure out what ion is coming from the compound. So we have lead, Cl2. If I have 2 chlorines, then that means that the charge on lead must cancel out the charge given by these 2 chlorine ions. And that is how we get lead 2. Let's look at one more example really quickly. So let's say we have MnI3. Okay, so the cation here is Mn, which is manganese. Okay, the anion is iodide. It's right. So iodide. This is iodine, but when we drop the ending and add "ide," we get iodide. Now, iodine, that was weird. Iodine has a charge of 1 minus, but there's 3 of them. And so the overall charge contributed by iodine is I3, times 3 is a total of 3 minus. And so in order to cancel that out, that means that Mn must contribute a charge of 3 plus, because 3 pluses and 3 minuses cancel out to give a neutral charge or an overall charge of 0. And so my cation must be manganese 3.